Now, the acute causes. Mr. George, I need your share, or I need your point of view. What is the main cause of kick?
Kick. This is uncontrolled. No. This is influx, which is migrate to the surface. This is a kick. And kick,
Yes,
and kick occur when the well becomes underbalanced.
Yes, of course, yes. If you get underbalanced, this is the main cause of kick. So this is the main reason. But we have branches or subtitle to the underbalance. Underbalanced means the main cause is to get underbalanced. Underbalanced means your formation pressure is greater than your hydrostatic pressure. And your hydrostatic pressure is 4.052 multiplied by mud weight multiplied by TVD. So is there any potential or any possibilities for the reduction of this constant? We can get underbalance by increasing of formation pressure or decreasing the hydrostatic pressure. Okay, so increasing the formation pressure due to encountering the abnormal pressure formation like under compacted shape. Okay, but the second reason of reduction in hydrostatic, reduction of this hydrostatic through this constant, is it possible to this constant to be reduced? No. So
mud weight.
Mud weight reduction.
Yes.
Okay, this TVD, is it possible to have an increase, to have a reduction, have a reduction in this TVD?
But TVD is TVD if we are drilling. So
TVD in the hydrostatic pressure law or hydrostatic pressure equation, it's the mud level. So we have a potential if we have, for example, losses. Yes, we have a losses. Okay, so we can go to underbalance through increase in the formation pressure, mud weight reduction, and drop in mud level. These are the main reasons for getting underbalanced. Causes of abnormal pressure, like under compacted shale, like artesian effect, like gas cap, faulting, bad sim job, and underground blowout. The cause which is included in the IADC will sharp, which is under compacted shale. All these reasons included in the IWCF. It's not included as the main causes for the abnormal pressure in the IADC will sharp. Under compacted shale means what? If you have a formation at 2000 feet, the overburden pressure above this formation, if you imagine this formation get lower or get deeper to be at 10,000 feet, the overburden pressure, more you get deeper, more the overburden pressure increases overlying this particular formation. So more you increase the pressure above the formation, if you have the porosity and permeability inside this formation, the porosity and permeability inside the formation will be reduced. So if this formation has a fluid like water, we will have a dewatering phenomenon. So the rule is, more you increase the pressure above or overlying particular formation, more you get escape or dewatering for the fluid inside this formation. Okay, but if you increase the pressure and there is no expulsion rate, there is no expulsion rate or removing the gas. Okay, just one moment. I have an important call, sorry, just one more. More you increase pressure, the expulsion rate will increase. But if you increase the pressure above the formation, or if the overburden pressure above the formation is high, what will happen to the expulsion rate? The expulsion rate will high too. So the scientist states that if you increase pressure and no expulsion rate and no dewatering, and there is no escape for fluid inside the formation, you have to expect you have a trapped pressure inside the formation. You have a trapped pressure inside the formation. So if you increase the pressure above the shale, if the shale contains gas or water, the shale has no permeability. So there is no way for escaping the fluid inside it. So if you drill this shale, you will create an artificial permeability by drilling, by removing an equilibrium state of the formation. So during the drilling is under compacted shale, you will have a trapped pressure. Then you will see, or the drilling crew will observe the large cutting with its splintery cutting over the shale shaker. And this splintery or large size of cutting, it's considered as a warning signs of kick, a warning signs, negative signs. It's required to conduct a flow check. Okay, so what's your solution to overcome this problem? Before drilling the undercompacted shale, what is our action to do?
Maybe increase mud weight.
Yes, increase your mud weight. Increase your mud weight before drilling this undercompacted shale. Why? To avoid this trap depression. And for your information, this undercompacted shale can cause also stuck pipe. Okay. Yeah. What is the most common cause of abnormally high formation pressure worldwide? Undercompacted shale. Yeah, trapped fluid in impermeable shale. Yes. What do heaving, spalling shale or caving seen at shale shaker normally indicates? Normally indicates increase in the formation pressure only. For your information, if you have an abnormal pressure formation, is it considered as a kick? Negative warning sign? Any negative warning signs or any warning signs for a kick indicates for what? Indicates for increasing the formation pressure. Increasing the formation pressure only, no another indication. We have only increase in the formation pressure. Negative warning signs of a kick or warning signs only. If you have a fast break, increase in ROB, increase the size of cutting, increase in torque. If you have increase in the temperature on the flow line, shale density decrease. If this undercompacted shale go with the splintery shape over the shale shaker, you will find it with the shale density, lower shale density. Why? Because this trapped pressure makes it lost the fluid inside it due to this trapped pressure. This shale is not drillable. It's just like this. It's not going to the shale shaker or over the shale shaker with a small cutting. There is no time to get under the cutter of the bed. Just to drill, it will escape or direct to the shale shaker above with large cutting size. So all these warning signs indicates to increase in the formation pressure and nothing else. It's required to conduct a flow check only. The second reason for reduction the bottom hole pressure is through the mud weight. The mud weight may be reduced through the barite cycling. We have another word for this barite settling, or maybe a barite sag, the same meaning. Settling or sag, the same meaning. Okay, barite settling or barite sag. If you a mud engineer and you don't adjust your rheology like yield point or gel strength, that leads the barite for settling, and then you will lose your hydrostatic. Then you will lose your bottom hole pressure. And also, if you have a barite as a weighting agent inside your in the mud, and you operate the centrifuge, this centrifuge make a separation for this solid, okay, or any weighting agent, and circulate for hole cleaning. Circulate for hole cleaning means operating your centrifuge too much time and pumping light mud. Pumping light mud, we have a question about pump light mud. If you pump light mud inside the string like this, the derrick man committed a mistake, and you make a suction for a light mud inside the string here. If you have a light mud here inside your string, what will happen to this bottom hole pressure? It will increase or decrease or still constant?
Decrease.
Will decrease when the light mud is go out.
To the annulus.
Yeah, through the annulus, yes. But if it's still inside the string, it will stay constant. The bottom hole pressure will be constant. And if you have also the slug, or if you have a slug or a high mud weight, this slug, you will have a gain inside your trip tank. You will have a gain inside your trip tank. But what will happen to the bottom hole pressure? According to the principle of YouTube, it will be constant. Why? It will increase when the slug or when heavy mud goes out through the nozzle of the bit in the annulus. But if it's still inside the string, light mud or heavy mud, the bottom hole pressure, as per the YouTube principle, it will be constant. Here, if you have a true vertical depth about the pumping light mud, if you have a true vertical depth like this, true vertical depth 9,800 feet. Okay, and the mud weight inside this well, it's 9.4 ppg. Mud from 3,800 feet to surface is to be displaced with 8.5. They make a displacement, or they made a displacement for this depth by 8.5 ppg. $3,800. So the rest of depth, it's 6,000. And he's asking you to calculate the hydrostatic pressure at the true vertical depth after the displacement. He's asking you to calculate the total hydrostatic, the bottom hole pressure. To calculate the bottom hole pressure, you have here a depth and mud weight, just multiply it by the constant 0.052, you will get hydrostatic pressure 1. And 6,000 true vertical depth and mud weight multiplied by 0.052, you will get hydrostatic pressure 2. So the bottom hole pressure, or the total hydrostatic pressure, equal hydrostatic 1 plus hydrostatic 2. Calculate it, please, and tell me the answer.
C.
See answer?
Yeah.
Okay. Let's check. Oh, yeah, C answer. Correct. Okay. Gas cut mud, background gas, or drill gas. The large umbrella, the gas cut mud, but we have background gas and drilled gas, or gas bearing formation. Gas bearing formation, background gas, drilled gas, all these idioms or terms are the same. Background gas, it's a known amount of gas. During drilling, the formation contains this gas, and it's entered the mud. It's a known amount of gas selected by the mud logger. We can know the percentage of this volume of gas by the mud logger. Okay, but it's called background gas or drill gas, called lag warning signs. Lag warning signs. Why? Because while drilling this background gas, the ROB is too fast. Why? It's a gas formation. So increasing the ROB, you will have also increasing of cutting, and this solid entered the mud and increased the mud weight. Increasing the ROB leads to increase the mud weight. After that, the gas will enter the mud and reduces the mud weight. So the ROB increases the mud weight, and the gas will reduce the mud weight. Two factors in the same time. You will not discover this change except the interval is too long. So it's called lag warning signs. Lag warnings. We have time to discover the background gas if you drill an exploration or exploratory well. And another type of gas called connection gas. Connection gas means if your hydrostatic pressure here, it's 1,600 psi, and you have an EPL just 200 psi. So your bottom hole pressure in this case, while operating your pump, it's 1,800 psi. The formation pressure, it's 1,800 psi. I think this is under balanced case. This is while operating your pump. This is dynamic bottom hole pressure. You have hydrostatic 1,600. You have an EPL 200 psi. So the dynamic bottom hole pressure is 1,800 psi. The formation pressure 1,800 psi. So if you're pumped off, here you will lose this APL. You lost the APL, and the bottom hole pressure will be 1,600 psi. Then you got underbalanced. You got underbalanced at which time? At the time of connection only. Getting underbalanced means you have a gas inside the well, small pocket of gas inside the well. Is getting underbalanced, is it a permanent? No, it's a temporary, while connection only. So you have a small pocket of gas inside the well. Okay, if you do not solve this problem in the another connection, you will have another pocket of gas, pocket by pocket by pocket by pocket. After some time, you will have a 3-barrel gift inside your active tank. So that means you have a kick. So during the connection gas, it's not necessary to get underbalanced immediately. No, maybe after some connections. How can we solve the problem of connection gas? How can we solve it? Yeah, I need your share.
Use the trip tank.
use the tryptase. How can we use the tryptase?
No, it's during drilling. Need to increase mud weight.
Increase the mud weight. Increase the mud weight by, we lost 200 psi. Okay, so this 200 psi we lost it during connection. So if you increase your mud weight by 200 psi, increase your mud weight by 200 psi. Take this 200, divided it by 0.052, multiplied by TVD. You will increase your mud weight by 200 psi. So during static, your hydrostatic will be 1,800 psi. And during drilling, you will be 2,000. So you will drill over balance. During connection, you will be 1,800. And during drilling, you will be 2,000 psi. So this is the first solution. What about the second solution?
Use MPD if you have money.
Yes, MPD. MPD. Yeah, third connection. MPD, why? Because it's used in the tight window, and the ABL is compensated by back pressure. This ABL that you lost it, it's compensated by back pressure, as we mentioned. Okay. And yeah, the third solution is to decrease your connection time. Decrease your connection time. And the fourth solution, decrease your control your ROB. And the fifth solution, after each connection, just circulate bottom up. Circulate bottom up to make sure you still have just one pocket inside the annulus. Does that make sense?
But practically,
We do not. Yes, practically, we do not apply this.
Yeah.
Yeah, we don't apply this. The company man will catch you from your neck. No, circulate bottom up each connection. No. Practically, this solution is not happening. But this is a theoretical solution for the connection gas. Okay. And temperature increase, as we mentioned before. If you increase the temperature, it will the viscosity will increase, it will decrease. Then you will lose your hydrostatic pressure due to barite settling or barite sagging on the bottom. Let's discuss the question. Yeah, Mr. George.
When drilling a gas formation in a horizontal well, what will
Yes.
the gas in the wellbore do? Will stay on the low side of the horizontal section, does not expand much into the horizontal section, but will expand more in the vertical section, expand a lot of the horizontals and compress in the vertical, does not expand in the horizontal section or the vertical section. B
answer, don't expand much in the horizontal section, but it will expand in the vertical section. Yes, and we'll discuss it later. Okay, but it's correct answer. Miss Anna.
Okay, the ground gas or cutting gas generally expand mostly in the wood part, the whole west quarter.
Could you please let me answer this question, please?
Yeah. Okay.
The back. Okay, tell me your answer and we'll discuss it. I just want to add just one idea.
I think it expands at any depth, actually.
Yeah, and your answer, Miss Anna?
I would say D, because I mean the rest of the last quarter halfway it doesn't make any sense for me. So I would put.
Okay.
I would put D.
The back. So I told you I want to add one idea to change your opinion. The background gas or connection gas, it gets out of solution, adds a bubble point pressure, and this bubble point pressure adds the last quarter of the hole. Okay, so the bubble point pressure, it is the pressure at which the first bubble of gas emits. That means start to leave the solution and start an expansion. So the connection gas or dissolved gas or a background gas is still dissolved or dissolving inside the mud till the pressure or take the last quarter of the hole, and it will make it will be a separate phase, not a soluble phase. It will be a separate phase at what? At the bubble point pressure, which is in the last quarter of the hole. What is the bubble point pressure? It is the pressure at which the first gas emits and considered as a separate phase and start to affect on the hydrostatic pressure. Does that make sense? So the correct answer, it's in the last quarter of the hole.
But it looks to be very approximate because it depends on many factors.
It depends on many factors, yes. Yeah, but this answer selected by IADC will sharp because in the last quarter you always find the bubble point pressure in the last quarter. Okay. Background gas. Yeah, your turn, Mr. Anna.
I would say it's B.
Gas that is contained in the rock, yes. Mr. Roman?
Yeah, which question? I think we finished this one.
Yeah, the first.
Okay, what is the hydrostatic pressure at the bottom of a horizontal well? The mud weight. Okay.
I think this is direct question. This is a TVD.
Yeah,
and
we use TVD.
Yes, okay.
TVD to calculate.
Here we have a reduction in bottom hole pressure or reduction in hydrostatic that leads the reduction in bottom hole pressure through the mud level. Gas expansion. The first reason is gas expansion. Okay. This gas expansion, as we mentioned, lead to hydrostatic pressure reduction. And this hydrostatic pressure reduction is compensated by a pressure, casing pressure. So hydrostatic pressure reduction, it's compensated by casing pressure. Then you will have an increase also in bit gain. And this gas expansion, it's prevented by shutting the well. If the expansion happen, it leads to hydrostatic pressure reduction. It's like steps, or step leads to another. Expansion followed by hydrostatic pressure reduction, followed by increasing casing pressure, and increase also in the bit gain. This expansion is prevented by shutting the well. But here, the gas still has another behavior like a migration, gas migration. So the gas has a light weight, so it will move from bottom to surface, and this movement it's uncontrolled. This uncontrolled movement called migration. This migration happens even if you like or don't like, even the well opened or closed. So it's uncontrolled movement, but the expansion will not happen if you shut in the well. Surge effect. What is the meaning of surge effect? Yeah.
When we run a hole fast speed maybe, and we make extra bottom hole pressure increasing.
Yes, running hole too fast, and also maybe you have a float valve, small clearance between the well and the string. You have a viscous mud, All these reasons lead to the surge effect. It's called a momentary increase in bottom hole pressure. Momentary increase in bottom hole pressure leads to losses, fracturing the formation, then losses. So these losses may be partial or complete. Partial, like if the return is worth 30%, now it's 10. So this is partial loss. And if it's complete, no return. So in case of partial loss, practically, what will we do if you have a partial loss while drilling? Yeah.
To pump LCM.
Pumping
Try to cure.
pumping LCM and all over the world, we pumping LCM. But we have an immediate action for the driller to do. Just stop drilling. Stop drilling. Reduce your pump rate, because the bottom hole pressure in this case while drilling equal hydrostatic plus APL. And this and that thing that leads the formation to be fractured, this bottom hole pressure exceeds the fracture pressure by a small value. So we need to reduce this bottom hole pressure. How can we reduce it? Or just decrease your pump rate to decrease the APL. After that, you will estimate the barrels that you lost, the loss rate. For example, if you have a losses 10 barrel in 15 minutes, that means in 1 hour I will lose 40 barrels. Then I will inform my supervisor. After that, okay, good job. I will decrease the mud weight, because he want to reduce the bottom hole pressure, so it will pumping light mud like that. It will reduce this a second factor as the second side of the bottom hole pressure. So the first action in partial loss is to decrease your pump rate to decrease the APL. After that, reduce your mud weight to decrease the hydrostatic pressure, to keep the bottom hole pressure lower than the fracture pressure. This is in case of partial loss, but in case of complete loss, there is no return. What is your action? Complete loss.
Start pumping in the annulus. Fill up. Try to fill up the well.
Yes, fill up the well by fresh water. Okay, what is the benefit from filling up the annulus by fresh water?
To get some more hydrostatic, at least trying to keep hydrostatic as much as possible.
Yeah, as much as possible, maintain the level of the hydrostatic. Okay, and the second reason, if you do not pumping a fresh water or filling the fresh water in the annulus, that means, or if anyone asks you about when will you have a kick, if you do not pump, or if you didn't pump a fresh water inside the annulus, you tell him, I don't know. Why? Because you want to monitor your well. If you didn't fill your annulus by a fresh water, you will not know when you have a kick. Okay, so the second benefit from pumping a fresh water inside the annulus, to monitor the gain and losses. That's why
Okay, I have a question.
Go ahead.
Two questions, honestly. The first one is connected, okay, we're gonna pump this fresh water, but what if we do have these sensitive shale formations in the annulus? What's that?
Sensitive formation like a hydrated shale?
Like, yeah, reactive shale and such.
Yeah, it's a big problem. Just fill the annulus by a salt water, increase the salinity. Increase the salinity, it's reduced the interaction between the hydrated shale and the mud. Okay? Because
And for example,
the main problem of the hydrated shale is the stuck. We have many types of shale, like a reactive shale, geopressurized shale, and all, and so on. This hydrated shale, the main problem is the reaction between the fresh water and the reactive shale. It goes swelling. So this swelling causes stuck pipe. So to change or to avoid this stuck pipe or avoid this problem, just use KCl polymer, use the oil-based mud, but it's expensive. Just
no, wait. I'm sorry, but we're talking about when we do have complete losses. So what we've just discussed is that, okay, we're gonna fill up annulus with fresh water. So that's my question, how we're gonna fill it up if we know that we do have reactive shales over there. So it can lead to stuck pipe and etc. I'm not talking about OBM and etc. when we do have complete losses.
And this depends on your situation. You have to assess your situation or your company policy. Many company in the development will start or continue drilling blind drilling. Maybe some company prefer to run a casing. Okay, but the main problem of this question, if it's applied on the exploration well, it's a big problem. Okay.
Okay, so
Because
it's not a solution for everything. Like
no, if you fill the water by the
just
if you fill the water by a fresh water, if you fill the annulus by a fresh water, you will have a reaction between the reactive shale and the water, and you will get stuck and cake, and it's a big problem. In exploration well, it's a big problem, disaster. But in the development well, it depends on the company policy. Okay, maybe running casing, maybe continue drilling blindly, and so on. Okay.
Also using mud cap for blind drilling.
Yeah, but this for in the surge effect or in this reason for reduction of mud level using the mud cap. This happened suddenly. I'm talking about the exploration well. Okay, but in the if you drill a development well, you already prepared your mud cap. Okay, you know this formation in the swab effect. Do you have another question, Miss Anna?
and the mud cap is part of MPD? Drilling?
Yes.
Okay, have we touched it before when we were discussing about MPD
No.
in this presentation?
No. Because why? Because we have many methods for the MPD. And I mentioned we have only one method, is surface back pressure, SBP. Okay? Swab effect. What does it mean, swab effect?
When you're pulling too fast out.
Yeah.
It's opposite to surge effect.
Opposite to surge with the same causes. But pulling out too fast, that means what? That means increase in the bottom hole pressure or decrease in the bottom hole pressure?
Decrease.
Decrease in bottom hole pressure, swab effect, momentary decrease in bottom hole pressure due to the same causes and opposite to surge. Okay, how can we know we have a swab?
By trip tank monitoring.
By trip tank. Okay, look at this. Here we have stand scoop. This is the first stand, second stand, third stand. Trip tank filled by 51 barrel. This is the volume in the trip tank, and this is the calculated volume, metal displacement. Okay. Each group 5 stand, metal displacement, and this is a trip sheet. And the question is, on the following sample trip sheet, identify the first evidence of abnormal fill-up that occurred. Each stand group all 5 stand and has a calculated displacement 3.78. 3.78. This is the stand group 1, 5 stand. We have 51 barrel in the trip tank, and this is measured the whole fill the trip tank, and this is the calculated. Yeah. Anyone can answer this question.
So, every group is the same number of stands, right? 5
Yes,
stands.
five.
And for C,
The answer yes. When pulling stand group number 4, why? In stand group number 4, we have in the trip tank only 3 barrel. We take from the trip tank only 3 barrel. So we have an increment by 0.8 barrel coming from the well. So we have a swap effect here. We have a wrong calculation in the trip sheet here. If you have a wrong calculation in the trip sheet, what is your action to do?
Flow check or go back to bottom and circulate bottoms up.
Flow check. You have two scenarios for the flow check, positive or negative. If this is 3 barrel, if this is 3 barrel, stay as it is, 3 barrel. This is negative flow check. Okay. So if it's negative flow check, what's your next step?
Shutting the well.
Negative flow check.
Oh, it
Run
means
back.
that we don't have a flow. Okay.
Yeah, we do not have a flow.
Okay. Yeah. Okay.
So your action is to run back to bottom. Yes, run back to bottom with open well and circulate bottom up. Okay, and if it positive flow check, this 3 barrel became a 5 barrel.
Then shut the well.
Shut the well and straight back to bottom to get lower or to get below the influx to be able to circulate it. Okay. Okay. So in case of negative flow check, just circulate bottom up, run back to bottom and circulate bottom up. And in case of positive flow check, we have 2 scenarios also. Let me tell you, if you have a positive flow check, you will straight back to bottom. You will have a reading in casing pressure and drill pipe pressure. This drill pipe pressure will be 0 because you have not a float valve only, but you have inside BOP. Even if you run back to bottom open end with no float valve, you have an inside BOP. If you pump to read the shut-in drill pipe pressure, and we will know that in the equipment part, you will have a shut-in drill pipe pressure and shut-in casing pressure. Those gauges will be the same. Why? Because you are off bottom. Because the gas is below, still below. While the drill string goes through this gas, and touch the bottom, if your drill string touches the bottom or at the bottom, the casing pressure will increase and the drill pipe pressure will decrease to be 0. In this case, if you see the shut-in drill pipe pressure 0, that means you have a swap. So positive flow check doesn't mean you always have a kick, maybe swap. But if you make the same scenario and run back to bottom and shut in and your string or your bit on the bottom, and if you see the casing pressure with a value and the shut-in drill pipe pressure with another value, that means you have a kick. Why? As we mentioned, the shut-in drill pipe pressure value means what? Means the value of underbalance. So in case of positive flow check, that means what? It's required to close the well. But does that mean we have a kick? No. Does that mean we have a kick? No. Just run back to bottom and check. If you run back to bottom and you check the shut-in drill pipe pressure 0, that means a swap. Casing pressure with a value and shut-in drill pipe pressure 0, it's a swap or influx or some gas inside the well. Just your action in this case to circulate bottom up with a closed well through the choke. Then open your well and complete or return or resume your operation again. Okay? After that, if you run back to bottom and the shut-in drill pipe pressure, and your pit on bottom, and shut-in drill pipe pressure with a value 200 psi, casing pressure with 300 psi, that means I have a kick. What is your recommended practice here? To circulate bottom up, also to circulate bottom up, and don't open your well. After that, don't open your well. So if you run hole and casing pressure and drill pipe pressure with a value, that means I have a kick. Your recommended practice is to circulate bottom up, and this is the first circulation drillers method. Then don't open your well and resume your tripping again. No, just go to the second circulation of the driller method. Does that make sense? Mr. Roman?
Yeah, it's clear.
Okay.
Yes.
Okay. So the idea that I want to deliver is conducting a flow check, and if it's positive, that doesn't mean we have a kick. No, it's required only to close the well. The same idea, if you have a warning signs of kick. Warning signs of kick means what? Means you have a kick? No, means you have increase in the formation pressure only. Okay? Okay. Yeah. Mr. Roman, could you please answer this question?
Okay, when tripping in the hole, mud returns to the trip tank are less than calculated. Once back drilling, the return flow is less than expected. What is the most likely? Partial losses.
Mud returns to the trip tank less than calculated. Less than calculated. In the trip tank.
Okay. It's tripping in hole returns less. Actually looks like a influx, but there is no such answer.
Yeah. When tripping in hole, mud returns to the trip tank. Mud returns to the trip tank are less than calculated. Less than calculated. Okay. Once back drilling, the return. Yeah.
For me, it looks like losses. E.
Okay, but here, the return flow is less than expected. What is the most likely cause? Here, if you have in the trip tank, mud returns to the trip tank are less than calculated. If I calculate the return of the trip tank here to be 3.8, and now it's a 3, that means what? That means you have a swap.
Oh, but I'm tripping in.
Yeah, but you're tripping in, that means you have a losses, partial losses.
Yeah, that's what I said. B.
Okay. The answer?
Yeah, B. Partial losses.
Okay. Okay. The second question. Mr. George.
Does a kick always occur after a total loss of circulation?
Yeah.
No, it depends of the mud level in the annulus and the formation pressure and permeability.
Yes.
B.
Yes. It's not necessary if you have a losses inside the annulus that leads to the a kick. No, it depends on the level of the annulus. Yes. Yeah. And also if you have a self-filling fluid valve, if you have a fluid valve failure, that maybe lead to a kick. If you have a fluid valve failure, maybe lead to the kick. Why? We have two types of fluid valve: conventional fluid valve, which is closed end, and self-filling fluid valve, which is open end. The conventional fluid valve, we have a disadvantages for this conventional fluid valve while you're running, for example, the casing. Because while running the casing, in the most of drilling contractor companies, while running the casing, they line up on the active tank, not to the tree tank, especially in Egypt here. So this, from the point of view of the well control IWCF and IADC with sharp, this is I think this lack of monitoring the gain and losses. So it's considered a disadvantage of the fluid valve, conventional fluid valve. And also, while running the conventional, while running the casing with conventional fluid valve without filling, maybe you will have a collapse for a casing. And also you will have an increase in the displacement. And if you forget to fill your casing, that means maybe you will have a U-tube from the annulus inside the string and failure for the fluid valve. So we have a disadvantage for a conventional fluid valve, which is a closed end. But the main benefit of the fluid valve, it's preventing the backflow to avoid the fluid valve inside the string while drilling, for example. Preventing the flow back through the connection or tripping. And this flow back prevention leads to avoid blockage or plug for the bit nozzle. This is the main advantage for the fluid valve while drilling, while connection or tripping. The IWCF and IADC will sharp inserted a type of a fluid valve called the self-filling or auto-filling fluid valve. It's open end, like this. Here we have a cooler, red cooler like this. We are running the casing with open end fluid valve like this. Consists of a red cooler, and this red cooler attached with this flapper. You're running the hole, lining up on the tree tank while running the casing, and you go fast, and the casing is automatic fill because you're running the whole open end. If you want to conduct or making your cement job, just increase your bump rate. If you increase your bump rate, this pipe will go down and leaving this flapper. So this flapper will close. It's converted from open end to closed end to one way valve. When will we do this? After running the casing and you want to make your cement job, just increase your bump rate. This pipe will go down, this flapper will be closed, and this open end fluid valve will be converted to closed end or one way fluid valve. Look at this, Mr. George.
What increases the risk of surging when running casing in the hole? Cleaning the hole of cuttings before running the casing, excessive casing running speed, condition the mud before running the casing, reducing the casing running speed. B, excessive casing running speed?
Yes. Yeah. Miss Anna.
Case centralizers are placed on a casing before it's run. They are beneficial to an effective casing job. Which of the following can be a problem when running centralizers? Create voids in the cement between, no increased chance of surging, prevents flow, increased chances of surging.
Yes, increase the chance of surging. Yeah, Mr. Roman.
Okay, that one answer is D. Swabbing induces losses.
What can cause a kick when running casing in the hole? Yeah.
Surging induces losses. The last one.
Surging, yes. Surging. Yeah, Mr. George.
Which of the following situation could result in a swabbed-in kick during a casing operation? use of a self-filling float that fails to convert, use of lightweight cement after casing has been run, failure to fill the casing while running in the hole, pulling the casing back out after getting it stuck. Means when you're going out in a swabbed in kick in casing operation.
Which answer?
Failure. Use of a self-filling float that fails to convert.
Read the question again. Which of the
Okay.
following situation could result in a swabbed in kick during casing operation? During casing operation, using
No.
self-filling fluid valve that fails to
No.
convert.
Pulling the casing back out after the getting in stuck.
Yes. Okay.
D.
Yes. 78. Yeah, Miss Anna.
But if it gets stuck, how are you gonna pull?
Pulling the casing back out after getting stuck. You solve the stuck.
Or solve the stuck and start to pull out?
Yes.
It's not the main
Casing.
point.
Yes.
The main point is that you start pulling casing. No matter stuck, no stuck. Yeah.
Yes, but the question of the IADC, I think it's maybe have many reasons, but we know the correct answer from the previous exams. Okay, from the previous exam. For example, if you use a self-filling fluid valve to convert, fails to convert. Fail to convert, that means cement job is prevented to do. We cannot do or conduct a cement job. If you even if you have a self-filling fluid valve fails to be converted to closed end, that means you'll still have a surface pressure through the cement job. So this is the first answer. Is asking about the swab. Use of light mudweight cement or lightweight cement after casing has been run. No, it's not a direct reason for this swab. Failure to fill the casing while running in hole. Failure to keep to fill the casing while running hole. That means what? That means you will have a failure in the fluid valve and you have a reduction in the annulus tubing up to the string. So the mud level will be reduced. So he's asking about the swab. But if he asks about the kick, swab the kick through the swab. Kick through the swab means we know the reason of the swab. Pulling out too fast. So we interpret this stuck or pulling out too fast after getting the stuck, after getting the stuck. So this answer.
But it doesn't make any sense. If you get stuck, why are you gonna pull out too fast? I don't get it.
Yeah, but I'm telling you about the correct answer about the IADC workshop.
I know. Okay, this is a correct answer because we're assuming that if we have a swab, it always pulling out.
There is
but
no
it
reason,
doesn't.
Yes.
But
There is
it
no
doesn't
reason
make
for pulling
sense if
out
you
too
get
fast.
stuck. How you're gonna pull out too fast?
The C answer is correct, and the D answer, if you pull out too fast, you will have a swab. But swabbed in a kick, my point of view, it's a failure to fill casing while running in hole. But this question, it must be rewrite again. You must rewrite this question again. Swabbed in cake, yeah, swabbed in cake.
What is the correct answer here?
The correct answer according to the IADC will sharp, pulling the casing back after getting it out stuck or getting it stuck. Yeah, but failure to
answer D. Yeah.
Yeah, but failure to fill the casing while running hole causes kick.
But we are talking about swapped kick. It means
yes,
we pulled something. It's easy.
This C answer causes kick. Why? Because you will have a failure in the fluid valve. As we mentioned, the level in the annulus will drop. Then you will have a kick. But pulling too fast or back out after getting stuck, even if we remove this word, this answer will be correct or will be more accurate.
Exactly.
Okay. I think Miss Anna is not satisfied.
Anna, just forget about
No.
stuck. Once you
Okay.
start pulling casing, you may swap.
Okay. Casing is running hole with non-return fluid assembly. Yeah, Mr. Roman, go ahead. What can happen if the casing is not kept full?
Answer D. Float may fail, causing mud to YouTube inside the casing.
Yes. Yes. This answer is converted to a question, and it's answer like this. Nobody. Fluid may fail, causing mud. Okay. To YouTube. Yeah, Miss Anna.
Okay, when running casing with a self-fill fluid assembly, what would indicate that the self-fill assembly is working correctly? Turns from the well equal closed end volume. Casing rotates freely, no. Casing rotation is limited, no. The turns from the well equal the volume of still run. Turns from the well equal stand. I think it's D.
The answer returns from the well equals the volume of steel. Yes. Because yeah, self-filling fluid valve, what would indicate that self-filling fluid valve is working correctly? Yes, steel only. Okay, Mr. George.
During running casing, if the autofill float valves to convert it to non-return float, what is correct from the following? Pressure must be applied from the anode to prevent your tube of cementing the casing. Pressure must be applied from the cement head to prevent the tube. Reverse circulation cement from the casing string. Pump lightweight cementing to anodes. It's correct from the following. Pressure must be applied from the cement head to prevent your tube of cementing to the casing string.
Yes, and this is a problem. And this considered a disadvantage for this self-filling fluid valve. If you have a cutting, if you have a small cutting still in this place, if you increase the pressure, this red cooler will not move down, and this attached will not close. This attached flapper will not close. And even we have also a limitation for this self-filling fluid valve in a soft formation. We cannot increase the rate in soft formation, so it doesn't have a wide range use. Okay. Yeah. Miss Anna, I think this question is yeah. You solved this question and number 86.
Yes, we've just answered.
Sorry, just answers. You solved it. Okay, failure to keep hole full of mud, and this is the last reason for the drop in level. Tripping, we have tripping weight or tripping dry. Tripping weight means closed end, and tripping dry or metal displacement plus internal capacity. Closed end and open end, that means you have a fluid valve or do not have a fluid valve. But tripping weight means metal displacement plus internal capacity. And tripping dry means metal displacement only. And in calculations, we do not have, look at this, we do not have any differences in calculations if you line up the trip tank and operate the pump of the trip tank while tripping between the tripping weight and tripping dry. Because you compensated the well by what? By the metal displacement only. Make sense? Okay. If you want to boil the string dry, just pump a slug here, and this slug, it's heavier than mud, and it leaves it leaves a length of pipe empty inside the string. As we mentioned, the bottom hole pressure will stay as the same as the header mud inside the drill pipe. But the bottom hole pressure will start to increase when the slug starts to exit the pit nozzle. We have two equations for the slug, 25 and 26. If you want to calculate the additional mud returned by slug, the trip tank volume, the gain inside the trip tank only, use equation number 25. And if you want to calculate the total mud returned by the slug, including the slug volume, use equation number 26. Let's apply it. Here we have a slug is pumped into the drill pipe. The pump is shut down and the well is shut in. And if you shut in the well, he's asking you about the value of casing pressure gauge. We usually don't make this closing the well after pumping the slug, but he's asking you about if you, it's a theoretical question, if you shut in the well to know the value of casing pressure. The value of casing pressure will equal the difference between the slug mud weight and your mud weight multiplied by the length of a slug multiplied by the constant. So this is the value of the casing pressure. Calculate it, please.
It's B.
The answer, let's check. 104, yes, the answer. Okay. During normal drilling operation. Okay, Mr. Roman.
So during normal drilling operations, 30 barrels of light mud is pumped into the string, followed by original mud. The driller shuts down the pump to observe the well with light mud still inside the drill pipe. Okay, question, how does this operation affect bottom hole pressure? Remains the same.
Yes.
Even no need to calculate because
Yes.
we still have a mud in the annulus.
Light mud is still, still inside the string. Yes. Yeah, Mr. George.
Your current mud weight is 11.5 ppg. You were instructed to pump a 35 barrel slug weighing 13.5 ppg. Your drill pipe capacity. How many feet of dry pipe will you have after the pumping?
Let me answer this question, please. Let me answer.
Okay.
Here we will use equation number 25. We'll use equation number 25. Here with the slug volume in the equation number 25, the bit gain due to YouTube, bit gain due to YouTube, use the volume of slug multiplied by the weight of slug divided by 11.5, your mud weight, minus 1. You will get the bit gain due to YouTube excluding the slug volume. So calculate it, please. 35, 13.5, 11.5 minus 1. So it's 6.0, 6.086 divided it by the drill pipe capacity, 0.0178. So 342 rounded up, it will be 342. Okay. Okay. Yeah, Mr. George, this question.
Before pulling out of the hole, you pump a slug. Immediately after displacing the slug into the drip pipe, you line up on the drip tank. Slug volume. Calculate how much mud would return to the drip tank.
Yeah.
The equation is the same.
Yeah, will be.
Correct.
Yeah. Okay, how much volume, mud volume return to the drip tank? Okay, it will be with the same way. Okay. After displacing the slug into the soil, he's asking about how much mud would return to the drip tank. So bit gain due to YouTube 25 barrel. Yeah, this is including the slug volume or excluding the slug volume.
Okay.
Yeah. Tell me your point of view. Here, calculate how much mud would return to the drip tank. How much mud would return to the drip tank? I think this excluding the by the same equation.
5 barrels should be C.
C answer 5 barrels.
Yes, 5 barrels. Yes.
5 barrels. 12, 10 minus 1. 5 barrels. Yeah. Slug volume 30 barrels. And he's asking about how much mud in addition to slug volume. In addition to slug volume. Look at this. In addition to slug volume, maybe use this equation, use the same equation, and add it to it the 30 barrel. Add to it the 30 barrel. So without calculation, I think it's 45. Let's try it. I didn't calculate it, but let's try it. 30 barrel. I will use the equation number 25 also. And this is 16.2 divided by 15.2 minus 1. Tell me the answer. 13 multiplied by 16.2.
1.97.
16 minus 1. Yeah, 1.9. 1.9. So 1.9. If we add it to the slug volume, he's asking about in addition to slug volume, would you tube from the well? In addition to slug volume, additional mud returned by the slug. In addition to slug volume, we have to use equation number 26. 26.
So it's 2 then.
32. 32. But
Why 32? It's 2 barrels.
two barrel. It's asking about the bit gain only. Okay. It's only one equation. In the IWCF, it's one equation. But if you want to include the slug volume, if you want to include the slug volume, use this equation plus the bit gain. And if you want to exclude the mud volume, use this equation. Just bit gain due to YouTube. Okay, it's only one equation. For example, use equation number 25 if you want to add the slug volume, just add the slug volume on the equation 25. And if you want to use only the bit gain, use equation 25 without adding or without the addition of the slug volume. Make sense? To prevent the confusion. Yeah. Miss Anna?
Okay, your current mud weight, you were instructed to pump your drill pipe capacity. What is the total volume returned to the surface? So it's assuming slug plus mud, right?
Yes, plus. Use equation 25
Okay.
plus the 35.
Okay, let me.
It's close to be 41, I think.
Divided by 35.
10.5 divided by
0.01.
11.5. By. Yeah.
Around 41.
Yes. 41. Equation number 26. But if you use equation number 25, the answer will be 6.08. Added to this mud volume, this slug volume, the answer will be 41. And if you use equation number 26, directly you get this value, 41. Make sense? Okay. Mr. Oman?
Okay, next question. I calculated already. It's I got 5.36.
Okay, 5.36.
Yeah, C.
Equation number 25.
Mm-hmm.
Yeah. Mr. George?
How are weighted pills used in drilling operations? To help reduce the chance of swabbing when tripping out of the hole, to make the mud level drop inside the pump when tripping out of the hole, to compensate for determining when tripping out of the hole, the above.
Okay. Yes, all of them.
The above.
Yeah, here we have a heavy bell or weighted bell. Weighted bell or heavy bell. Look at this. We have here, it's divided into the slug pots, ECD bell or mud cap or trip margin. Trip margin. This is the benefits of weighted or heavy bell. To help or reduce the chance of swapping when tripping out of the hole, this is the function or dimension of the ECD bell. To make the mud level drop inside the pipe when tripping out of the hole, it's a slug. To compensate the hydrostatic for hydrostatic underbalance when tripping out of hole, it's a spot. Okay? Different idioms or terms under the large umbrella, which is weighted bells or heavy bells. Yeah. Where is the best place to put the heavy bell? In the vertical section, in the vertical part of the well. And how do you calculate the volume of weighting bell? By using this equation. Just calculate the height and then calculate the volume. Calculate the height by using this equation. Then calculate the volume of bell. Here, a weighted bell is pumped into the well as pipe is pulled out of bell. What will happen to the bottom hole pressure? Yeah, Miss Anna. Need you share in this question? Could you please answer it?
Decrease.
Yes, because it will get shorter. The level will drop. So it will decrease. Yes. Mr. Roman.
Severe losses occurred while drilling. The pump was stopped and the mud in the well could not be seen. The well was then filled on to the top with water and remained static. Okay, mud weight, brine water weight, height of water column. What is the reduction in bottom hole pressure with the 150 feet of water compared to the pressure before the losses? Okay. 1 second. So will be difference between columns of water and mud. 12 ppg minus brine 8.6, and then multiply by 0.52 and 150 feet. 26 psi.
Yes,
C.
26 psi. Now, we have a losses through this feet, 150 feet. The mud weight is reduced through this depth, or through this true vertical depth, by the difference between the 12 minus 8.6 multiplied by 0.052 multiplied by 150. So this is the reduction in hydrostatic or reduction of bottom hole due to these losses. We reduced by the difference between two mud weights, and we calculate the hydrostatic. It's 26 psi. Yeah. How can the location of pills in the well bore is determined, Mr. George?
How can the location of peels in the wellbore be determined? As the stroke counter every pumping the peel. The stroke counter says peel. Okay. Include enough of CM. If we set the stroke counter, the peel starts down, the drill pipe and keep track the stroke pumped. Here I set the stroke counter when the peel starts down, and the drill pipe and keep track of the strokes pumped.
Yeah. Yes. Okay. Yes. See answer. How can a bill be spotted in the correct place? I think the same idea. Estimate the volume of bill and convert it to strokes. Yeah, Miss Anna?
Okay, let me read first.
It's the same question. The same idea of the previous questions that you answered.
Yeah, get shorter.
Yeah, that's the same.
Yeah. B.
The answer?
I put B.
The bill will move.
Peel. This pipe is stripped out. It will move down. D.
The answer, yes. The bill will move down and in the well and will get shorter as the pipe is pulled through it. Okay, Mr. Roman?
I have a question here in
Yes, go ahead.
67. The peel will move down. Okay, we have peel inside drill pipe, yes? And we're pulling.
No. Inside the annulus. Inside the annulus and
already.
Yeah. And you pull the string out from this bill. So it will get shorter. It will get shorter. The level of the bill, look at this.
Here it means peel is in the annulus, right? It's not in the drill pipe.
Yeah, in the annulus.
Okay.
If this is the level of the bill and this is string inside the bill. So if you pull the string out of the bill, the level of bill will get shorter and go down.
Yeah. It means we spotted the peel on bottom.
Yeah.
Okay. Okay, 68. What should be done with the weighted peels when tipping back into the well?
The practical, it's a practical question. It's circulate the bell out in stages. Don't get lower the bell and circulate it one time. Just go down and divide this bell on stages and circulate it to avoid increasing the pressure. Okay.
Yeah, we will have to circulate if we want to continue drilling. Or...
Yeah. So this is B answer. Okay. Let's take a break just for 10 minutes, then we'll come back. 10 minutes.